Hi, today I want to talk a little bit how to implement a small do-it-yourself emergency button with the ESP32. This implementation is inspired by Andreas Spies, a video about the Amazon Dash button, and he also talks about how we can use it maybe as an emergency button. So I take my editor and implement a solution for the ESP32, but you certainly should check the channel from Andreas Spies, and the link from the video is in the description.
Grüezi YouTubers. Here is the guy with the Swiss accent.
So in my point of view, the functionality of the device should meet 5 requirements. First, the device should be battery driven and the battery should last for years. The message that would be sent out should not produce extra costs, and the message should send for reliability to more than one recipients, and also for reliability the button should only use one or just a few services to implement the functionality. And also for some security reason the communication should be encrypted. So for the long-term usage I would use a LiFePO battery and an N-channel MOSFET and an help push button. For the messaging I would use email because it's free of charge and it also fits the requirement for the more than one recipients. And we only have to use Wi-Fi and simple mail transfer protocol in a secure version, and no other web services interfere with our solution. And for the communication we use SSL or TSL, and we use the encrypted version for the mail sending. So to implement our solution we can use a high side push button or also a low side push button. I would use a low side push button with an N-channel MOSFET, and we can discuss this later in the video. And if we press the push button the microcontroller will be switched on, and the switching would also smoothed with some smoothing capacitors. And if the microcontroller is on, the first thing he has to do is switch on the gpio pin for the N-channel MOSFET and drive the gate of the MOSFET high, and so the MOSFET will be switched on, and you can release the button but the microcontroller will be still on till he switch the gate of the MOSFET off. So it's some kind of latching circuit. And after doing our message sending, the microcontroller will then turn the MOSFET off, and so the whole microcontroller lose his power and also switched off, and the battery is no longer used and can stay for the next usage without losing any power. For the MOSFET we can use a part from Alpha Omega Semiconductor or from International Rectifier or now Infineon some parts. I would use the AO3406 or 3402, or from IR I would use the type IRLM-L2502 because it's a logic level switching MOSFET, just the purpose we need. And all of them have common that they only have a small drain to source leakage current for about 1 microampere. And also a very low on resistance. For the battery I would use a LiFePO because it's just have the right voltage level we needed. And for the smoothing capacitor I would use 2 or more capacitors because of the different switching frequencies we can produce with our push button. And we have to smooth them out so we don't have unexpected behavior for our ESP32. And here you can also see my bench setup. I use the GPIO pin 25 for the gate of the MOSFET, and with GPIO pin 26 and 27 I also display some messages for the user, just an indicator if the message is sent or there's some error with the message. So in case of error you have to press the button again. And only for programming and debugging purposes you have to use the UART converter, but you have to disconnect it for the real usage with the battery. So before we discuss the source code, and as always you can find that at GitHub, I first show you the example run. So first thing we have to do is to flash our software to our device and then press the reset button, and we can see in PuTTY the debug messages and the connecting to the Wi-Fi gateway, and also the connecting to Gmail, the Google Mail server, and connecting with our own account we have to configure. And after we successfully logged on, we can send our message to the recipients. And then just we signal the GPIO pins, so the green LED is switched on, and after some time we switch the whole device off, so we switch the GPIO port 25 to 0 or low. And this is the bench view, so we press our help button, then we see that the power indicator is on, and also we see that the message successfully have sent it, and also on our mobile device we receive a mail, and we can open it with the Gmail application and can have a look what's going on. So here we can see our USB to UART converter, our indicator LEDs, and also the N-channel MOSFET for the low side switching. And just for the future videos I can show you the ESP32 adapter that I created with KiCad. But before we can discuss the code, there's just one trick before we can use our Gmail account from our ESP32. We have to turn on the access for less secure apps, so the ESP32 can use our Gmail account. So I suggest to don't use your YouTube account as a Gmail account. I'd use it just for the demo purposes only. So for a real device, just create a new account and use this account. And please don't try to use your ESP32 as an IoT spam device. So let's just dive deeper into the code. Before we start, I show you first how you can use Eclipse as a development platform. I just use Makefile projects with existing code, so you can use my code as a start for your code and just use Makefile project with existing code. And also you have to set some properties, just the path and the symbols you have to set. And this is my setting, and I've exported the settings for you to the include file XML, so you can use this file for your own starting with the development. So this is just a quick startup for usage of Eclipse, and then we can have a deeper look into the example. I use the HTTPS GET example, but I also use some examples from the ARM and Mbed mail client. So it's just a mix for some code from others, and then I just put my own thoughts into this code. So I also use the abstraction layer for the hardware from Arduino, so it's easier to drive the GPIO ports. And here goes all the mail configuration into this defines. So you have to set up your Gmail account for the sender and also the receiving Gmail accounts, or you can use other email providers as well. And in this two defines, you have to set up your account, you have set up your user and also your password for your Gmail account. So only if you put the right defines into the variable, you can use your Gmail account for sending emails. So that's just for the beginning. All other things are the same as the standard example. There's just one addition. This is the startup sequence for using the GPIO ports. So we just set the main power GPIO port to high, so the MOSFET can switch on, and all other GPIO pins we set to low and configure them as outputs. So then we initialized our Wi-Fi with our Wi-Fi SSID, and also your password you have to set in the configure file. So maybe we can show this SDK config. So it's something here. So I've just used an example hot zone. It's your SSID and also an example password, but you have to change it for your own purposes. So that's initializing the Wi-Fi, and here are some SSL configure codes from the embed example. It's just an SSL handshake and an SSL data sending, and also an SSL data write with a response. And this is the simple mail transfer protocol secure client. So first we have to set up the SSL connection and check the certificates for the encrypted connection. And I also put here the certificate for the Gmail server, so you can have a look into this. So if our secure connection is successfully started, we can use first a handshake to see if our mail server is online. Then we write an extended hello to the server, and if the server responds with an OK, we can establish the authorizing login. Then we send our username and also the password in base 64 notation. Then we write the sender address and also the recipient address, and we can repeat this for every recipient we want. Then we write the data code for our message, and as you see, repeat the from, then we send the subject and also the message body. And if the mail server responds with OK, then we can close our SSL connection and everything is fine. So after we successfully send our message, we can check the status. If something goes wrong, we write our red LED to high, and if everything is okay, we write our green LED to high. And after some waiting time, we also then switch our main power GPIO to low, so the whole device is switched off. And that's all. So if you have any suggestion for improvements for this project, please share your thoughts with the whole community in the comments. Thank you. So as always, thanks for watching today, and I hope you learned something, and if so, please give me a big thumbs up and subscribe to my channel, and also activate the reminder for new videos so you can have all the infos in real time. Thank you and bye bye.